So, welcome to a new edition of the Heat Treat Podcast. I'm your host, Carlos Torres, and today we'll be talking about gas nitriding. We have one of the power players on the industry, all the way from Los Angeles, California, on an actual recording studio full with rock stars, Stephen Christopher. How's it going, Stephen?
Carlos, I'm doing wonderful. Yourself, buddy?
I'm doing fantastic. And, I was actually shocked when I saw that you're in a recording studio. If you can just move just a little so the camera can focus on the guitar. So go ahead.
Oh, I just thought to myself, when you asked for me to be on this, which, by the way, thank you so much for inviting me. We can't talk about Los Angeles and the rest of California without being in a recording studio. So
so this is pretty cool because this is actually what we're trying to do. We want to make this industry sexier, and what's more sexy than to talk about gas nitriding with electric guitars and a recording studio. So we're making this industry cool again.
Make the industry great again. There you go.
Make Heat Treat cool again.
Yeah,
that'll be your slogan.
Well, hey, I tell you, a lot of people that listen to you weekly may not know that you're a bit of a rock star yourself. So,
yeah, I am. There's another channel for that. I'm gonna post the link. But thanks for sharing that. I remember those days. And I have never performed on a bar on California. That one of my dreams. One of my favorite bands is The Doors, actually from Los Angeles, California. So
absolutely.
When you just showed me the guitars and that you're based in California and we were going to talk about gas nitriding, I felt super excited, right? So it's great to have you on the show, Stephen. Thanks for taking the time. I know it's early for you, and we have a great internet connection. You are in HD. I believe it's the best connection we ever had on the podcast. So thanks for making this happen.
Hey, setting records here.
So today we're going to talk about gas nitriding, applications, the industry of California. We're going to talk about aerospace, which is like the main thing in California, but also on the West Coast, and not only in California, all the way to Seattle, right? So there's a lot of industry over there. And Stephen grew up on Michigan. I believe Michigan or Ohio, right? You were in the Midwest.
Correct, Midwest. I was born in Indiana.
You were born in Indiana, and you started your professional career on heat treatment on the Midwest, full with automotives, carburizings, nitridings, big pusher lines, and you moved some years ago to California, to the West Coast, right? So we want to talk about how different is one location to the other one, and the goal here, it will be for people in the Midwest that haven't been in the industry of California to understand what's different there, what's similar, what are the most common practices, which are not, and just to, and backwards, right? The people from California that they're used to working on this type of, aerospace industry with their type of ovens, furnaces, you name it. How is the Midwest different, and how it's similar? So this is what we're going to talk about. We're going to focus mainly on this episode on gas nitriding because you are an expert on it. So can you share a little bit of your of how did you started, how did you got involved in the industry, and how did you from being a young engineer, you got some nitriding experience and you traveled all the way to California, and right now you're like the coolest dude talking about heat treatment on a recording studio, talking about gas nitriding. Can you share that with us?
Yeah, so yeah, I did. Out of college, I got into pharmaceuticals, actually, of all things. A far cry from heat treat, and I immediately realized that I wanted to work somewhere that I could work on things. I wanted to use my hands, my brain, everything, and somewhat randomly ended up in heat treat, and I definitely haven't looked back. I immediately fell in love. So yeah, I worked with a commercial heat treating shop in central Indiana. And what was really neat about that was, you're right, we did have all these automotive and different things, but we were a NADCAP accredited shop. So I think for people to think of the West Coast as being, where aerospace is king and lives, are missing out on the fact that there's aerospace everywhere in the U.S. and really probably everywhere in the world. So
you started in Indiana. You said the Was it the first job you ever had on the heat treat?
In heat treat, it was.
So you have been all your career on heat treat.
Before I was in pharmaceuticals for a bit. Before,
you said that. Okay.
Years, yeah. So then when we got into heat treat, yeah, like I said, it was a NADCAP shop, and you know,
But you said it was mainly automotive, right?
It was mainly automotive. Absolutely,
Right.
that's what kept us locked in Indiana. But we did a bunch of nitriding for them.
Right.
For the industry. We also had, you know, carburizing furnaces, plasma nitriding furnaces, vacuum equipment. So for me, it was a great learning experience because I was able to work on, you know, really all the equipment that supplies our industry nowadays. And yeah, long story short, I had an opportunity to join, you know, with Super Systems, and eventually made my way into Cincinnati, and then ultimately out here to California.
Right. So going into subject, what was the first thing you noticed when you moved to California that was a little different from the Midwest?
Yeah, so first thing is probably just the scale, and I like to paint this picture for people that have never been out west. You know, when we think about out west, right, we think about you know, Phoenix, and then we think all the way up to Denver and maybe the Northwest and Portland. All those places add up, but Los Angeles is specifically a monster in itself, and it's really hard for people to appreciate how big this industry is, and really all industries in Southern California. So I took down some notes here, but there's this one location in Los Angeles called City of Industry, and it's like 12 square miles. Okay, it's just a little piece.
City of Industry?
City of Industry. So listen to this. So this City of Industry was founded in the 1950s, okay? It contains 3,000 businesses, about 67,000 jobs. I can think myself of, you know, 20 to 30 heat treaters between commercial and captive in this one city. And guess how many people live in City of Industry? 219 people.
So they're the population of the City of Industry.
200 people, 67,000 jobs. I mean, that's the kind of industry you're talking about in Los Angeles specifically. It's just it's
so
amazing.
Where is it located? It's north, south, east or west from Los Angeles.
It'd be just east of like Los Angeles proper. Mm-hmm.
Like an hour drive or something.
Well, you know, that's all relative, right? It could be a 10
Well,
minute.
yeah. You're right. So
that's just one of the places. There's so much areas like that out here that.
So Los Angeles is so big that they have like a section. They created a City of Industry.
Yeah, they literally just said, "Hey, you know what? Let's just make industry here." I mean, you can imagine that in Detroit, we have a city of transmissions, so to speak. So I think that was the big thing for me, was just learning how massive it was out here.
How often do you go to the City of Industry?
Quite frequently.
Yeah. Well, so you said the density of the City of Industry on heat treat, it's considerable. And now going to your second question, one of the common conceptions about California is that it's mainly aerospace, and you and I have talked about it. There's a considerable amount of aerospace, but there's other applications. So, you know, what's the size of each niche, of each market? You know, if you take aerospace, I know that there, well, on the West Coast, because if you could describe a little bit, you know, the West Coast is not only California. Of course, California is a big part of the West Coast, but, you know, there's aerospace. I believe there's some castings. I know that you also travel a lot to Arizona, right? Mm-hmm. So can you explain us how does the industry, you know, takes place on each section of the states of the West Coast?
Yeah, well, certainly the West Coast is dominated by aerospace. I think
80%, 70%, just a very ballpark number.
I'll be very political here. I'll say 50%. That way,
50%,
I'm right on the fence. It's likely more than that. So aerospace offers this huge part, but to limit it to that is missing out on a lot. There's a lot of machine and tool and die manufacturing all the way from Arizona into Los Angeles. You start going up north into, you know, Idaho and Wyoming and all these other areas that you might not think of as having a lot of heat treat, and they do. Everything from, you know, the medical industry in the Northwest, Portland, Montana, you know, Idaho, all these places have a lot of medical. To firearms manufacturing, all the way from Arizona, you know, extending north. So there's just a lot of industry and a real diversity of industry out here.
And the supply chain is the how can I describe this? Because California is well known for the space. It's a very big, it's a very large state, right?
Mhm.
So the distances that are traveled from the commercial heat treater to the source, are they in the range of 2 hours, 1 hour, 30 minutes? What's like the standard there?
Well, I mean, with any city, I think a couple hours is not unreasonable. But this is kind of a funny point. So I live somewhere between Los Angeles and San Diego, and I had a brother that lived in Phoenix prior to me moving out here. And when I called him one day and said, "Hey, I'm moving to Los Angeles," he said, "Oh, that's funny. I was going to tell you I'm moving to San Francisco." Well, anyhow, he's several hours further away in San Francisco, living in state now than he was when he lived in Phoenix. So it's an absolutely huge state.
So one of the things that when you say aerospace, that it's the dominant market on California, we hear a lot about Tesla on California.
Mm-hmm.
So do you know if Tesla has their own heat treat department in-house, or they outsource?
I don't know if they have any. I do know a few facilities that do heat treat work for Tesla in the Bay Area.
Right.
So they at least outsource some of it.
Well, which of the processes are done for Tesla? Is it gas nitriding or carburizing LPC? Do you know?
No, I think a lot of it is more just like a typical heat treating. So
okay. Everybody's talking about Tesla right now. So if you're there, I believe it will be nice to share. The heat treat part of this big company. Everybody's talking about Elon Musk and SpaceX, and so these are the type of companies everybody wants to work. Well, the new guys they want to work to. So it's a nice way to introduce our industry to the new guys.
Absolutely.
Go ahead.
No, I think Tesla's an interesting one, and like I said, I can't confirm their internal heat treat or not. But I know SpaceX for sure does have their own captive heat treat. But what I think is interesting when you start talking about Tesla is not just the thought of, does Tesla have a heat treat, but what does Tesla bring with it? As this starts to grow and they talk about opening a plant in Nevada now instead of the Bay Area, what's that going to bring with it? And I was looking at something Bob Finken had shared with me some automotive numbers from last year about the U.S. production of typical gas vehicles going down from like 17 to 14 million. Most companies down 12, 15%, except for the electric vehicle market. It had increased 10% last year. And that's not all Tesla. It's all the companies that are supporting them. So, I think that offers a lot of heat treat and, battery type companies that are going to require services. So
great news to hear. So going a little deep into the main subject of today, gas nitriding. So the mission of this podcast is to transfer information from the experts of the subject to the viewers, right? So if a heat treat engineer wanted to know about gas nitriding, and he looked on YouTube and found this video, how would you describe the nitriding process, the gas nitriding process? What are their applications? And if you could describe a typical cycle, what happens with the ammonia, with the part, what we're trying to achieve, wear resistance, fatigue, right? Share with us a little bit of gas nitriding. So from one power player of the industry to the world, gas nitriding.
Gas nitriding in 2 minutes. Here we go. So
you can take five.
5 minutes. All right. Well, we're going to go deeper then. So gas nitriding is just a lower temperature, at least relatively compared to carburizing. So a lower temperature diffusion process. And that's really at its core. Most gas nitriding starts with some type of uncracked gas, which again differs from carburizing in that we're dumping in raw gas to a furnace at a low temperature. Those gases could be anything from ammonia and nitrogen to possibly some type of hydrogen carrying gas. But anyhow, what's really interesting about nitriding is that you don't have a generator necessarily. So all this gas is getting dumped into the furnace, but then something inside the furnace, some source has to ultimately dissociate those gases. And without dissociating it, you don't get the nitriding potential, which is ultimately what we care about and try to control. So that kind of brings up this really cool part of nitriding that a lot of people don't at least think of when they start talking about it, which is nitriding is dependent on more than just the sum of the parts, right? In carburizing, you have a carbon potential, you dump in a certain amount of gas, and not trying to make it sound simple because it's not, but you ultimately get some type of result, some type of repeatable result with same flow rates, things like that. Nitriding's wild in the sense that, if you run parts with twice the surface area or double the surface area, you may need to adjust the flows. And that's where, really having a good knowledge of how dissociation and surface area and, surface roughness, things like that really come into play for the parts you're trying to heat treat.
And can you describe a little bit more about the gases that we actually use and the DA for the viewers?
Yeah, so most nitriding starts with not DA, but just anhydrous ammonia or some type of uncracked ammonia.
Well, let's explain what's DA. It's dissociated ammonia.
Dissociated ammonia.
This is like the main variable we want to look on the nitriding process. Whenever we have like a carburizing process, we look for the carbon potential. On gas nitriding, we always talk about DA, which is called dissociated ammonia. And so is that accurate to say?
Absolutely. And we make a lot of assumptions when we talk about what we're measuring to ultimately, when we talk about DA is how much hydrogen is inside of the atmosphere. And then we can derive a lot of things from there. But one of those critical things is what are the gases going in? If we don't know the inputs, we can't calculate the outputs, right? So if we're dumping nothing but raw ammonia or even DA, which is purely nitrogen and hydrogen, we can calculate how many hydrogen, or measure how many hydrogen atoms are there, and then determine what the dissociation may be. Because ultimately that dissociation is what's going to allow us to build nitriding potential and ultimately control case depths and hardnesses, white layer, things like that.
And the assumption is that most nitriding processes are done on pit furnaces, electric pit furnaces. I believe that's the common denominator, but I have seen other furnaces that are not pit furnaces in which you can actually do FNC plus nitriding. Do you have experience with those?
Yeah, there's a couple different furnaces, and you're right. Most of them are pit furnaces, many with removable retorts, some without. There's definitely a big push now for horizontal furnaces. So more like what you think of it.
Nobody likes to dig pits.
Nobody likes to dig pits. Absolutely. It adds cost. Especially when you're talking about used equipment and, different depths and heights and whatnot. And then there's difference between, models that are purged with an inert gas versus ones that offer some type of like vacuum pumping system. And of course, when you're talking about a vacuum pumping system, that, changes the design of the furnace as well. So
explain a typical cycle for a standard nitriding application, gas nitriding application. I know you have to purge the furnace. I know you have to add nitrogen on it to a certain temperature, right? You have to purge it 3 times before adding ammonia, because ammonia can be explosive, right? Below a certain temperature, and after another temperature, the ammonia will start to crack. So can you explain a typical cycle, a standard cycle for gas nitriding?
Yeah, absolutely. So you hit it dead on. One thing that if you're going to talk nitriding, one thing you have to talk about is what happens before the process too. Because I think in heat treat, a lot of times, we think about walking onto a shop floor, and you have all these men and women racking parts and putting them in fixtures and putting them in baskets, and then somewhere they go down the line and get processed, right? Nitriding is very sensitive to cleanliness, very sensitive to how we rack parts, things like that. So that effort needs to really be, magnified, I think, in the process. It's very, very, very important. So anyhow, we got all these different, pre-processing steps going on. People even consider like selective nitriding, where paints or things like that are used, or even mechanical limits to stop nitriding on certain surfaces of the parts. So let's assume we've got through that. Everything's racked up. We've got everything ready to hang and go into the furnace. The next consideration is the fixturing itself. Unlike having all these just baskets that we run through time and time again, nitriding is. I mentioned earlier, the parts, the sources of dissociation. We want the parts to dissociate gases, not just random, fixturing. So that's also important. So anyhow, now we get ready. We put all these parts inside a furnace. We close it up, and either through somehow we're going to remove all the oxygen from the furnace.
Right.
Very
We don't want
common.
oxygen. We don't want oxygen. That's
Oxygen leads to danger, right? So many people just start flowing some type of inert gas for, like you said, maybe 3 to 5 volume exchanges.
that's nitrogen mainly, right?
Yeah, nitrogen purge mainly. That can remove all the oxygen, and then may have an oxygen sensor or something like that to prove that. Otherwise, a lot of the newer furnaces, to speed that process up, even offer a vacuum pump. So they'll pump the furnace down to remove all the air, and then do some type of backfill the process with to move into the nitriding cycle. So all right, so now we got rid of the air, right? We got rid of all the oxygen. We're ready to heat this thing up. Most nitriding's performed almost half the temperature of carburizing, so 900 and some degrees, 1,000 degrees, but not much more. And while that's going on, the system is controlling different gas flows, and that's flow of ammonia, dissociated ammonia, hydrogen, different nitrogen, different types of gases, and we're measuring the amount of usually hydrogen in the furnace to determine how much dissociation there truly is. And that's really the critical measure. If we can control the dissociation, if you can control how much hydrogen you know is in the furnace, you know how much nitriding potential there is, and you produce good parts.
So I believe this is like the key. After you do the purge and you start adding ammonia, you have to control the DA, which is the dissociation. Mm-hmm. How do we control that? How do we measure that? Can you explain that to the viewers, to the audience? Do you take a sample out? Do you have a sensor in? Are you measuring how the gases behave? So is there a PID control on gas flow or not? Can you describe a little more? Because I know this is your strength, right? The control side of it. So how do you control the dissociation, which is going to give us a great nitriding result?
Yeah, so the key is a clean, pure sample from the furnace, and normally there's enough pressure within any furnace, because once again we got rid of all the air and oxygen to begin with, right? So the last thing we want is to introduce air and oxygen again through leaks. So we're usually running a furnace at some type of positive pressure, enough that it's definitely not going to pull back any air from the outside, right? Mm-hmm. So normally we sample from the exhaust line. Is a great place, and run that through some type of hydrogen sensor. There's even newer technologies where you can sample directly from the furnace. So, maybe like sampling through the lid of the furnace. But ultimately, that's just measuring the hydrogen concentration inside of the furnace. And from there, if we know the gas types, this is the critical. If you know the gas types, the nitriding potential, right?
Mm-hmm. And so we have purge chamber. We're at temperature. We have no oxygen. You say 900 degrees, right?
Yeah, 950, 1,000.
Well, we're 1,000 degrees, right? So we start introducing ammonia into it, and we start to having a dissociation. There is something also the catalyst. I know the retorts, they have to do of a certain type of alloy in order to accelerate the dissociation process. Can you explain us a little bit of why the alloy is important? I know that we always talk about Inconel 601, and I know guys that they want to save some money, and they do, and they make the retorts of 330, and sometimes they start to lose the cracking, the dissociation. So explain us a little bit what's not the chemistry itself, but why it's important to have this particular type of steel on a retort or a catalyst.
Yeah, absolutely. So you hit it right on. Inconel 600, 601, or some type of stainless steel 330 equivalent makes for a great retort that's going to last for many, many years. But ultimately, what it comes down to is to go back to my statement earlier, we want parts dissociating ammonia, not the retort. If the retort's dissociating, all that's happening is you're going to dissociate gas. You're going to measure that. But then it's just going to get dumped out the exhaust before it actually diffuses into the parts.
So we want the parts to be the one that be cracking ammonia.
We want the parts to be dissociating ammonia, absolutely.
Okay.
And that really localizes all the the nitriding potential to the part surface, which is what we want, and it gives us a way to offer repeatable control.
And the cycle time, what's the typical time that you leave the parts to nitride once you have got into temperature to 1,000 degrees and you start cracking ammonia? What's the typical time frame? And this depends on the density of the load or the type of the or the white layer that you want to get. So, but typically, what is a time frame for a cycle time of gas nitriding after we have gotten to the process variables that we need?
You've been in heat treat too long, Carlos. You know, there's no typical process time.
I know. Actually, yesterday we were talking to a guy on plasma nitriding that stated, the process can go from 6 hours to, I believe he said something like 72 hours. It was something crazy, right? But it gives you an idea of the range.
So it's much closer to that than it is typical carburizing times. It's going to be much similar to plasma nitriding or ion nitriding. And you're right, it can be 6 hours up to, I think, 72 hours is probably the extreme case, but certainly 24 to 36 hours is very reasonable, especially in processes where you're trying to really do a lot of fine white layer control, which is where we typically do that in what we call a second stage, where we're trying to build up case and then either remove it or at least control it.
So you mentioned another key term in nitriding is the white layer. The beauty about nitriding is that we eliminate distortion because there's not like a quenching media, right? It's not going to distort the parts and it's low temperature. Plus, you do not get all that oil impregnated on the parts and the parts go out kind of clean, right?
Right.
The main reason why we nitrite stuff is in order to add wear resistance to the part and a little more resistance to the fatigue. And we do this by getting white layer on the part. Can you give us a little bit of the chemistry of how a white layer is formed? And I'm talking about when we do nitriding, the objective of nitriding is actually to get particles of nitrogen going inside the part to forming the white layer, right? But give us a little more of the chemistry that goes on, because NH3 it's ammonia, right? And when we say about dissociating ammonia, is that we have to separate the hydrogen for the nitrogen. Just if you could just go a little deep into that for the viewers. Sorry to put you on the spot, but you're the expert on the subject.
You're putting me on the spot with white layer, but I tell you what, I've got I guess now a future podcast for you to do, and we'll get one of our metallurgists on here to answer all these questions.
That'll be fantastic. That'll be fantastic, because I'm not a metallurgist myself. I know your strengths also on controls, and this is what we want to do. We want to network, and if we talk about nitriding, it's a very wide subject, right? But we have metallurgical guys, we can have furnace designers in here. I know that you're a great friend of Chuck Thomas, who is like the PhD on gas nitriding. So I assume you're referring to him, right?
Yeah, I'll throw him one. So Chuck was my mentor. He's when I go back to the original conversation about working in Indiana and coming into heat treat and having no idea what was going on, Chuck was my boss. And I learned anything I know, I give back. I throw back to Chuck. He taught me. So.
Watching the camera, Chuck, you're the man. We can't wait to have you on the podcast. So if you could make that happen, Steven, that'll be fantastic.
It's on my list.
All right, got it. So, something else. Well, which are the most common misconceptions about nitriding?
Most common misconceptions.
Well, I'll give you an example. One of my most common misconceptions is that they only can be done on pits. And you just stated that you can do it in other type of furnaces, right? The misconception is that you need an electrical pit furnace with a bottle of ammonia to do nitriding, but there's so many other ways to do gas nitriding.
Yeah, I think any type of secured retort could ultimately be used for nitriding. To go back as an example. This is on a tangent here, but we built a nitriding furnace many, many years ago, and it was out of a 55-gallon drum and pretty much a coffee can, and as long as it sealed all the gases in it, it was able to nitride. So,
well, I'll tell you another, misconception that I have is that nitriding is mainly done. The big companies like to outsource it, because ammonia is not a friendly gas to operate on big corporation because it's very smelly. So it's not user friendly because it gets a lot of leaks. So will that be accurate to say that the bigger companies, they want to outsource nitriding because they don't want to deal with ammonia?
I certainly think that there's some, some environmental concerns in terms of, having to deal with the local authorities and,
Well, I'm not local authorities, but I don't know if you've been. I'm pretty sure you've been around an ammonia leak. It sucks big time.
Yeah.
If you have to be, working on a furnace with an ammonia leak, it sucks. Well, the good thing about it is your sinus will go off.
The good thing is
But
you can't get fooled. You're around ammonia or you're not, right? There's no hiding
yes,
it. So
yeah, there's no hiding it. But
you're not baptized
it's,
as a nitrate, right?
it's not a friendly gas. So that's one question. When you have an ammonia leak, you know it for sure.
Absolutely.
Unless you had COVID and you can smell it.
Unless you have, there you go. There's the one group
Right.
people cannot notice.
Right. That's another way to test for COVID. Go to
any
heat treat
shop,
shop,
anywhere USA.
right?
Walk
Right,
in.
and if one of your operators can smell it, he's positive. Right.
There you go.
Right. Right.
Man, we're solving all sorts of problems today, and we haven't even talked about the rest of heat treating.
So you don't want to have you don't want to stick in your nose go to a nitriding shop and see if you can smell ammonia.
It's the ultimate test. The CDC should be calling any time now to get this set up for us.
Right.
No, all joking aside, going back to your captive question about why these why captive shops may or may not have nitriding, I don't think it has to do with the ammonia. Permitting, everybody's got corrosive materials. They follow the MSDSs. So I don't think that's what shies people away. I think it's that nitriding is just a really intricate process where you have to understand all the components going into it. And to really get on a fine scale here, surface area, surface preparation. We have so many people that run beautiful nitriding for years, and then all of a sudden, get a batch that deviates, right? And they don't know why it is. And so what's everyone do? You go to the furnace. Furnace isn't it? You go to the controls. But a lot of people lose sight of, if you put parts in that are compromised, it's really got a huge impact, especially on nitriding. And that could be cleanliness, surface area, surface prep. Especially you talk about getting into stainless steels. Did you do something to break down the chrome oxides on the surface so that it is even willing to accept nitrides? So there's a lot of discussions that need to be had with nitriding. And I think that's what inhibits people from possibly bringing it in-house. But the good news is there's a lot of great equipment manufacturers out there. There's a lot of great controls companies, and I don't think it needs to be as overwhelming as maybe it once was. So
another misconception about nitriding, specifically about ammonia again, is that all the piping has to be made out of stainless steel. Piping and valves, because ammonia is corrosive, right? I believe it's a good practice to have stainless steel pipes and of course solenoid valves, stainless steel type. But I have seen many facilities that they only have the valves made out of stainless steel, but not the piping. Have you seen something similar to it?
Yeah, absolutely. And I think everyone goes to stainless, which is just a wonderful decision. But you don't need to. There are different local codes.
You don't need the stainless on the valves, right? On the solenoid valves.
It's not really that you want stainless as much as you don't want some other materials. So, for example, what's every valve made out of that you buy? Every hand valve. It's got brass components, right? Mm-hmm. Brass is an enemy of ammonia. It'll eat away at it. So it's not so much that you want stainless as much as you don't want some other wetted materials to be part of the valve. Stainless is a great option, but even black pipe's a good option. Most local code with depending on the schedule of Schedule 40 versus Schedule 80 and how the threaded connections or welded connections are, allow black pipe to be used as well.
So this is one of the keys of running a lean process of a safe process of gas nitriding, but also you have to have certain interlocks, because you cannot open just the furnace at the middle of the process like you can do it on a carburizing furnace with a flame screen. Mm-hmm. So what are like the main safety interlocks that you must have and that people need to follow, because I believe most of the accidents are made because human mistakes, right? Mm-hmm. Because they don't follow the automatic Interlocks. So share a little bit of that with us, the Interlocks you see, because I know you're a great expert on PLCs and working on interlocks and furnaces.
Yeah, so I think a lot of people when they get into trouble is during something we deal with a lot, especially here in Los Angeles, and that's power outages, right? When things
Okay.
are running, nobody's got a problem. It's when things go wrong and then you get a little worked up and excited. That's when people make mistakes. So the big one you touched on earlier, it's oxygen.
Oxygen.
Things don't explode without oxygen. That's just it's that plain and simple. So I think the big thing is to understand what's inside the furnace, and if you're unsure what's inside the furnace, treat it like it's flammable. Most of these pit style furnaces, you guys make them, and I'm sure where the lids held on with some type of lever or different types of bolts, whatever it may be. You can loosen those things up whenever you want. Not a lot of the furnaces have the big locking rings like we see on positive quench furnaces where the PLC does interlocking. So the big thing is just understand what's inside the furnace, and also with nitriding, when in doubt, open the nitrogen. Every furnace should have a nitrogen line on a normal.
I really like what you said earlier. I believe I'm going to start just quoting you. If you don't know what's inside the furnace, treat it like it's flammable.
Absolutely.
That's great wisdom, right? So because there's a bunch of this industry has a lot of new guys, right? Mm-hmm. that they get they get in the heat treat department and they know very seldom about it. Maybe operators, maybe maintenance guys, that they know how to maintain a machine, but they do not know how to handle an atmosphere, which can be explosive, right? So a great advice to give them, if you don't know, if you do not have certainty on what's inside the furnace, treat it like it can explode. Treat it like it's
absolutely
flammable.
The difference between a furnace and a bomb is letting air get in there, right? So yeah, be careful. And also, I don't think you can scrap out I've never heard of anyone scrapping out a job because they put in a little bit of nitrogen for 5 minutes, right?
Oh no, nitrogen is
and then
it's a winner.
Yep. Absolutely.
Every time that you have well, the thing is when you don't have nitrogen available, or you don't have a power emergency plant.
Yeah, so are you seeing that? That's a question I guess I'd have for you. Are you seeing a big push in I know nitrogen making on-demand nitrogen is becoming a bigger thing. I see in places rather than having a big bulk storage tank house. Are you seeing that on equipment you guys offer?
I am seeing it. Nitrogen, of course, is an added cost to the furnaces. The thing with nitrogen is that the big companies started to charge you a lot for a storage tank, the big bottle tank. Mm-hmm. And they will charge you if you use it or not, like a fixed fee or like a minimal fee. And for the plants, the companies that use nitrogen in other processes will make sense. But for the plants that they just need nitrogen, if something goes wrong, right? Mm-hmm. I don't think managers like to see that costs added with no. Just like a safety variable, but there's been a push on nitrogen generators, right? They're not that expensive because you don't need a level of purity, as the medical industry, and you can have very a nice nitrogen generator, and you can have a small bottle, right?
Right, as long as you just try to keep your 3 to 5 volume exchanges. Right. You have a tank that it's being filled that you can ultimately purge out if you have to, right?
Right. On our heat treats, I do not have a nitrogen tank. We actually are in the process to get a nitrogen generator for other processes, but it's always a plus to have a bottle with nitrogen available. But we do have power plants in the event that we get a massive shutdown. And I can tell you, when there's a big storm or something like that, there's always a call at 3 a.m. in the morning. But when you have like a plan B, you feel really safe about it. But to answer your question, yes, I have seen a big push on nitrogen generators, and what I can share is that if the company has other applications for the nitrogen, they'll have it as a backup for the furnace operation. But if they do not have a site, one process aside safety on the furnaces, the costs can go up a lot. So
Yeah.
that's where it will make sense to have a nitrogen generator.
This will be an interesting one to watch in the next few years as we see
Yeah.
more and more of these.
Yeah, I know there are a couple of companies that are being very aggressive selling nitrogen generators, and it's like the endothermic generators, right? When they switched from nitrogen methanol, you needed to have two bottles of nitrogen methanol and then a big mixing system, and the trend is that everybody's migrating to endothermic, right? You want to make your own gas. And you want to make the amount of gas that you need for your application. So
absolutely, and then there's a lot of new stuff even now that
sorry, we lost a little track of gas nitriding, but nitrogen is a big thing about it. So but I tell you what, if you have a gas nitriding application, you need to have an ammonia bottle. I don't think there's like an ammonia generator.
A source of ammonia, correct? A source of raw ammonia. Usually that's like an anhydrous liquid ammonia that gets converted into gas. So absolutely.
Mm-hmm. So going back to the Midwest and California, which are the big difference from one market to another? Because I know that in the Midwest, in Michigan, in Ohio, you name it, it's very automatic, very big pusher lines, a lot of carburizing, a lot of oil quenching. Of course, there's other side processes. I believe there's a lot of LPC, vacuum, right? High pressure gas quenching on big units, right? It's a lot of production. It's big volumes for big programs, right? And when we go to California, I believe you will find loads that are lesser on size but more expensive on price. The load will be an engine or a turbine. I don't know. So what have you find? Which are the main difference?
Yeah, so I tell you what, I think California is the best spot to talk about this, right? Because everyone talks about what do you love about California, and I say we got a little bit of everything. We can surf in the morning and ski in the afternoon, right? So we got it all. And I think processing is the exact same. You're right, we don't have these huge pusher lines that are just pumping out, cheap nuts and bolts all day long. That doesn't really exist out here. But what does exist out here are really, really small furnaces and then really, really big. So I remember, when I first moved out here, I saw a bunch of these, you remember the older like Ipsen T style furnaces that,
I do.
Loads in and out. Some of these that would process racks the size of shoe boxes. I mean, have you seen in the Midwest an automotive company running shoebox sized trays through a batch furnace?
I have not.
Not right. But I thought it was crazy, and I said, "Oh, okay, man, I found the unicorn. I found the one and only." And I started to go to more shops, and I realized there's more of these out here, than I thought. So there is a lot of small, like boutique processing going on for the aerospace industry. But on the other end of that, go up north, go up to the Portland area, Seattle, where you have all these suppliers of Boeing. Those a lot of the turbine components begin as a cast material, and that's a single pour cast for an engine that's 5 feet tall. Can't put that in a small furnace. So you have a lot of really, really huge vacuum applications out here, bottom load furnaces that employees are racking parts standing on the base of the furnace itself, and reaching way over their head with thermocouples because the parts are taller than they are. So you really have everything out here, and then everything in between.
So my follow-up question to this: so whenever you have a pusher furnace, you have to have thermocouples and sensors, and you have to do surveys on a pusher furnace, right? And when you have like a tiny furnace running shoebox stuff, right? I believe since it's going to be a critical flight component, you're going to load that thing up with way more thermocouples than you will do the pusher line, right?
The 9-point survey stays king.
9 point. So 9 point.
Absolutely. Now there's ones where you start to see many more, up to 30 and 40, but the small survey, it's the small furnace still is 9 thermocouples.
Because you cannot afford to scrap an aerospace load, right? You just can't.
Absolutely, absolutely. I remember working on this. This was another humbling thing coming out to California. I remember working on an aerospace supplier. They made tanks that ultimately ended up in space. Okay, so first off, that's pretty cool. You want to
It
attract
is. It
people
is
to treat putting stuff in space, Carlos. I mean,
rocket science.
it's rocket science. So anyhow, I remember talking with these guys. We were working on a vacuum furnace with them, and I heard the big plant manager come stomping out. And long story short, in manufacturing costs, he claimed to have $500,000 to $600,000 in one of these tanks that we were getting ready to run. That puts a little.
How big was the tank?
I'm going to say it was 8 foot tall and 3 foot in diameter, something like that. But made out of some space age material, right? But $600,000. That puts a little.
Pressure on you.
It raises the stakes a little, the poker stakes a little bit, right? When you're putting that into something you just retrofitted and worked on. So lots of cool things out here.
Yeah, you better have your checklist double watch, right?
Yeah, that's you gotta have everything crossed off and T's crossed and I's dotted for that one.
Yeah, so it will be accurate to say that the same amount of investment that you need to have on a pusher line will be the same amount of investment that you need to have I'm talking about instrumentation and surveys, right? Because you need this instrument. Let's say it's $1,000 just to round the numbers on a pusher line, which is running massive parts, right? But for a tiny furnace, you need the same level of accuracy.
Same level of accuracy. I mean, the different instrument types, the different furnace types, it's not so dependent on the size of the work zone.
Mm-hmm. And you mentioned, so 9-point survey is the one that rules in aerospace, right?
As a general rule, yes.
Okay, and SAT?
Yeah, SAT is a really big one, and everyone's always done it. I think that's just been a big push for automating that process and simplifying it, because it is a lot of paperwork, right? So
it is.
It's good news also there. There's a handful of companies now that are really offering nice packages to simplify that process.
Well, the thing with those companies is I believe that there are many, because the application is very wide, but they're very seldom that actually understand heat treat. And we talked about this. There's a lot of explosive things going on furnaces. So if you have an SAT company or a TUS company, you want to make sure that they understand heat treat, because they're going to be opening and closing furnaces.
Absolutely. And then a lot of times these same guys are adjusting PIDs when something doesn't control well. So you really want somebody that's got a lot of knowledge with furnaces, not just calibrations and those types of practices.
Yeah, well, I was going to ask you about this. I don't know how familiar you are right now with the travel restrictions with Boeing, but I believe in it was last year, 2020, January, February, before the major lockdown, the aerospace industry was having a boom. The delivery times for planes were two or 3 years per unit, right? So has it slowed down with everything that's happening, or the demand for those planes is still ongoing? Because the orders were placed, right? I don't know if you can cancel and sorry to put you on the spot again, but
no, they can, right? They can cancel, because that's what happened with the Dreamliners, right?
Yeah. So you see this production still going on, and as the aerospace industry, the commercial flight industry, nobody's traveling right now, but they're staying keeping heat treating stuff right now on Boeing?
Yeah,
or for Boeing?
Yeah, so it's so odd. So first off, I mentioned that there's a lot out here, right? A wide variety of production. Most of these aerospace heat treaters are all diversified, right? So whether it's DoD work for Department of Defense or something else, they're finding ways to keep the lights on. So I think you may disagree, but out here, I think everyone was really prepared for 2020 to be a terrible, terrible year, and it didn't end up being that way for a lot of people. At least not as bad as they maybe thought it was going to be. But what's odd is the disparity that we see. So I can go into two companies, Company A and Company B, right? And I visited this exact scenario end of last year. Both companies supply to Boeing. Tier 1 suppliers make pretty similar parts. Company A had probably laid off half their people. Maybe they were going to lay off more, and things were really dismal, and it really concerned me to see that, you know, and for any industry, let alone, you know, obviously ours. Company B I go to, they're doing the same thing. They told me they're sitting on 6 months of back orders. So I don't know what that difference is. I don't understand how the same, I mean, COVID disrupted travel, that disrupted the plane supply chains, right? How can
Right, but the backlog complaints was 3 years already. That's what I'm asking, right?
I don't get it.
You know, I also have heard. Well, I read an article lately that, you know, like bicycles spiked up on the market. You know, everybody bought a bike.
Yep.
Everybody bought a boat, right?
Yes.
And believe it or not, a lot of people are buying private jets. Well,
Wow.
the ultra rates, right? So there's some market to it.
Absolutely. Absolutely. Well, it sounds like you and I will be buying some boats at a good price here in 3 years then, huh, Carlos?
I thought you were going to say we're going to buy company jets, but I don't think I don't think it's we're there yet. We have to have many viewers.
Okay. Well, as long as I can ride your coattails on the way up, I'll be riding in your jet. But let's be glad you didn't buy a dog. You have to take care of that for the next 10 years, right? That's the other thing people bought a lot of.
Well, bikes, boats, yeah. Also, the one other booming market, and I believe this has to do a lot with gas nitriding, are the Polaris and the adventure vehicles. Everybody wants to buy like a dirt bike or a Polaris or those type of things. Well, I have seen that those things right now that we have a lot of idle time and we have to be you know, with social distance. Everybody's buying like a sports vehicle. So that's another market that I believe took off really quickly with this pandemic.
Right, quads and razors and all those the like. You're right, tons of them.
Mm-hmm. Well, so this is one of the best the parts of the show that I enjoyed the most. The next one, it's called Heat Treat Hack or Heat Treat Gadget. You know.
All right.
So you know, it's right now like a hashtag trend to talk about life hacks and stuff. So we decided to make a section called the Heat Treat Hack or the Heat Treat Gadget. Is there a heat treat hack that you specifically have that you use on a regular basis that you would like to share?
Well, I mean, if I share everything, I would be putting myself. No, I'm kidding. So let's stick with nitriding. How about?
Okay.
I mean, that's been the topic of today. I like to think I've got a lot of hacks in life, but let's stick with this one. So I talked about all these different inputs that go into nitriding, right? You got 10 different inputs, and if you don't understand all of them, you don't understand why things are changing. But the most common one we get is I ran great parts for a year, 2 years, whatever. I got a problem. The numbers measure the same. I got the same dissociation. I got the same temperature. I got the same time of heat. What's my problem, right? Sick furnace test. This is something nobody talks, well, a lot of people know, maybe nobody talks about, but it's a very simple, we call it the sick furnace test. Every decision starts with a fork in the road, right? Let's start with the furnace. Let's make sure, let's prove it that that's not the problem, and then we can move on to the fixturing, the parts, the process, everything else. So anyways, what is the sick furnace test? In nitriding, we're just going to take everything out of the furnace. Don't put parts in it. Run an empty furnace.
Not even fixture? No fixture.
Start with no fixtures. Okay. Start with no fixtures, and we'll get there. So heat the furnace up, purge it just like you would a normal process. Heat it up to, like we talked about, 950 degrees. And then flow a low volume exchange. So by low volume, I would say like, you know, one volume exchange of the retort. So 30, 40, 50 cubic feet, whatever it may be. And watch the dissociation. What happens? We talked earlier about these, you know, Inconel and, you know, 330 stainless retorts. They shouldn't be dissociating gas. So if they are dissociating gas, that's a problem. And of course, certain amount of gas is going to dissociate just naturally, right? So what do we say? Maybe about 15%. Certainly you want to be below that. But if you're dissociating 30, 40% in an empty furnace, guess what? You got a sick furnace. So now we at least got a starting point, right? Now let's go the opposite direction. I'll say maybe we don't have, you know, maybe we have a really good dissociation in an empty furnace. Go ahead and, you know, below 10%, 15%. What do? Throw your fixtures in. Run another sick furnace test. Add the fixtures. But it's just one step at a time and build up until you know where your problem is. I use this example. We worked on a furnace 5 years ago, and 3 years ago got the call. Got a problem. asked them to do this. They said they'd been hunting for leaks and 10 other things for a couple weeks, their maintenance department. We said, do this simple test. Guess what? The furnace dissociated like crazy with empty. We said, well, what's going on? So you start digging around, you start looking for it. They ended up finding a weld that was repaired. One of their maintenance guys had repaired a weld with a non-stainless type rod, and that was dissociating a ton of gas. So they ground it out, they fixed it, and next thing you know, they're buttoned up and running again. But that's my hack. Understand the equipment, understand the furnace, and the sick furnace test lets you make that first decision, and then keep adding parts until you get there.
Sick furnace test, huh?
Sick furnace.
You should register the brand or something.
We trademark that one?
I know. You know what would be cool? If I don't know, if you have like a checklist for this sick furnace test. I don't know. You will mind sharing that with us, and maybe we can post it on the description of the video.
Absolutely. I'd love to.
I'll make sure Tim actually reaches you and they post it on the video. So if they want to do a sick furnace test, they know how to have what to do. Like the 1, 2, 3 of the sick furnace test. That'll be fantastic.
Absolutely.
Right. So Stephen, it's been great talking to you about gas nitriding. I actually did learn a lot. I'm not a nitriding guy by any means, but speaking to power players gives me a lot of insight and valuable information. Thanks for doing that. Going now to a little added value to the new generations, because right now the heat treat industry, the heat treat community is fighting for talent with the startups, the fintechs. Everybody wants to work in these shiny big companies, right?
Yeah.
And as I tell everybody, we are on a very interesting, passionate industry. If you were to give a personal advice or experience to a younger guy, or if you were to travel on time and speak to yourself when you were 20 years old, what would the advice be?
Oh, good question. Advice to my young self. First off, I think you touched on something interesting that I'd like to add to. You mentioned, heat treat, the personnel, right? We have these people that are very passionate about our industry. I think there's actually two people. There's ones that last about 2 weeks because they get a little dirty. Mm-hmm. And they're gone. And then everybody gets past that 2 weeks tends to stay for 20 years, right? Because
they smell the ammonia and they quit.
The ammonia weeds people out really fast. So I think it boils down a group that really wants to be here and cares. People don't want to move on because they genuinely like our industry. One question I've been asked of late a lot is about people in the industry and how can we increase that, right? I mean, it's hard to we have a labor pool that's difficult, and a lot of times we're fighting for talent. You mentioned earlier trying to make this exciting, right? Make heat treat exciting. I think one way we could do better as an industry is, I think this doubles the workforce, attract women to our workforce. We have definitely a very male-dominated workforce, and I think it's maybe just because it's a dirty industry and nobody wants to do it. But it's a really exciting industry, and I think we need to do a better job attracting women to it. And all of a sudden now we've got twice as many people doing it. So anyways, back to your question, right? So you asked about life advice for my younger self. I think if you would have asked me this question a couple of days ago, I would have said one that I heard on a previous podcast you had, which was just to build up your contacts, right? Build up your personal Rolodex of experts. Networking. So that really would have been my first answer, but I'm gonna not bore anyone with the same answer as before. So, I think I'll go twofold on this one. Number one, we all get a little bit fiery at times. So my first advice to everyone, and not joking here, anytime you type up an email that maybe someone's offended you or upset you, don't hit send that night. Wait till the next day. I mean, how many times have you've probably been upset with somebody, Carlos, right? Yeah. That email never is effective on the first day. So don't wait till the next day, polish it up, send it, and it tends to hit target. The next one is probably just confidence in, the scientific process. We talked about this sick furnace test, and really it's nothing complicated. But when you look at scrap parts, what happens, right? People get overwhelmed. It seems like a really big task. But one of my favorite sayings before is, how do you eat an elephant, Carlos? How do you eat an elephant?
By parts.
One bite
One
at a
bite
time. One bite at a time. So every problem seems large, but it's really just a bunch of small problems hanging out, and you just got to sift through those small problems until you get to the answer. So that's my other big one. Have confidence and learn to not get overwhelmed and go about any problem as just a series of small problems, and solve one, prove it's either the problem or not, and then move on to the next one. But ultimately, whether it's a stack of AMS papers or specifications that you got to try to get compliant with and seems overwhelming, or a furnace that's got bad parts or a valve that's not opening, it's just a matter of thinking through the process, and you'll get there. They always do.
Thanks for sharing that. Just before ending the show, can you move a little so the camera can focus the guitars again for the guys that actually just forwarded?
You haven't listened to anything I've said, have you?
I just been watching the guitars and trying to get a clear image. Sorry about that. I'm a guitar player and I liked it.
Yeah. Well, the good news is apparently studios are open at 8 a.m. anytime we want, Carlos. So as long as this is the time, apparently rock stars don't like working early. Something about being a night owl or
you're right,
staying up late. So I don't know.
That is fantastic. Hopefully the next time we see each other, we can go to that studio and actually record a live podcast.
Live podcast together. There's
on a Rockstar studio.
Absolutely.
That'll be fantastic. So that was Stephen Christopher talking about gas nitriding. Thanks for your time, Stephen. Let's talk again in the short term. Hit subscribe to the channel, the Heat Treat Podcast. It is on LinkedIn, Spotify. If you don't want to watch the video, you want to be, at the gym or working out, you can watch. You can hear about Heat Treat during that time. Driving the car. It's on Spotify under the Heat Treat Podcast. We have a couple of episodes already recorded once a week. Stephen Christopher, all the way from Los Angeles, California. Thanks for being on the show, man.
Hey, see you around, Carlos. Thank you.